And welcome to my YouTube channel. I am Arthur Francis Deban. Today we're going to be handling or dealing with chemistry, and the topic therein is concept of isotopy and isotopes. An isotope is a process, a phenomenon whereby elements having the same atomic number but different mass numbers. And it is in this concept of isotope or isotopy that has given rise to different element or certain element having their mass numbers being probably like chlorine being 35.5, the point therein, or copper being 63.5. It is because of the isotopy. Now we say certain element that exhibit this isotopy. Example, hydrogen, which we have the protium. That is it has a mass atomic number of 1, of course, and a mass number of 1. We have deuterium, which have an atomic number of 1 and mass number of 2. We have the tritium, which have an atomic number of 1 and a mass number of 3. And chlorine has 2 natural occurring isotopes of 35 and 37, with their atomic numbers being the same, 1717. We have other elements such as oxygen, which we have oxygen or atomic number of 8, mass number of 16, 17. And we have potassium, atomic number of, mass number of 39 and 41. We have argentum, mass number of 107 and 109, carbon, 12 and 14, copper, 63 and 67. So we are going to look at the relative atomic masses of isotopic elements. So we say, however, the relative atomic mass of an element that has 2 or more isotopes depend on the percentage or relative abundance of each isotope in the naturally occurring element. All right. So most elements have 2 or more isotopes. For an element that has only one type of atoms, no isotopes, the mass number is equal to the relative atomic mass. For example, the mass number of sodium atom is 23. Its atomic mass is the mean or average of the isotopic masses. This explains why the relative atomic masses of chlorine and copper all give us 35.5 and 63.5, like I said earlier. So we're going to carry out certain calculations to determine the relative atomic masses of these elements that have different isotopes, and see how we're going to be able to get the 0.5 or therein or thereabout in these calculations. So we have 2 methods which we can use. We call the relative abundance in ratio form. It depends on how the question is given. And we also using the percentage abundance. So the relative abundance or the percentage abundance. So we solve different questions and see the different means which we're going to use to solve them. An element has 2 different isotopes. Okay, let's call them X20 and X22, which occurs in the ratio of 1:3. These 2 occurs in the ratio of 1:3. We understand that X20 occurs in the ratio of 1. X22 occurs in the ratio of 3. Now, let's say we should calculate the mean relative atomic mass of X. So the relative atomic mass of X is what we have to do. So since this is an isotopic element, which means we have to be able to calculate it to know the relative atomic mass, unlike certain other elements, which atomic mass are defined directly because they are not isotopic in nature. So let's take a solution. This is the given, the variable that has been given. So for us to do this, we say the relative atomic mass would be, the total ratio here is equal to 4. Don't forget that. So first thing is the atomic mass of first X multiplied by the ratio 1. The second multiplied by the ratio 3, divided by the total of the ratio. So now I'll be having, the first one is 20 times 1 plus 22 times 3 all over 4. And this is equals to, so we have 20 times 4 will give us 20 plus 66 perhaps. 22 times 3 will give us 66 over 4. And this is equals to, we add the 86 divided by 4. First of all, this is 86 over 4. And this finally becomes 21.5. So the relative atomic mass of this element X is 21.5. So let's take more questions so I'll be able to differentiate the two methods which we are using. Okay, let's take question number 2. In question number 2, we say naturally occurring chlorine atoms contain 75% of chlorine 35, 75% of chlorine 35, and 25% of chlorine chlorine 37. Chlorine 37. Now, in this one, we're dealing with percentages. The highest percentage, the total percentage here is 100. So it's still the same thing. The percentage here multiplied by the mass number and the percentage multiplied by the mass number over the total percentage. So the relative atomic mass become 75 times 35 plus 25 times 37 all over 100. And this is, let's see what we get. 75 times 35, 75 times 35, 2625. 2625 plus 25 times 37, 925. 925. This is over 100. And this is equals to 925 plus 2625 is equals to, this is 3550 over 100. And this is equals to, so when we divide by 100, we have 35.5. 35.5. So the reason why chlorine is having its atomic mass to be 35.5 is because of its what? Isotopic what? Nature. So we'll take more questions. Yeah. Question 3. Okay. Okay. An atom of the same element X has atomic number 8 and mass number of 16, 17, and 18. Remember, all of them will have atomic number of 8 because say isotopy, a phenomenon whereby same element have the same atomic number or different mass number. So if that guy if the atomic number is 8 for the X that have 16, will still be the same 8 for that one that has 17 and 8 for the one that have 18. What is responsible for the difference in the mass numbers? Why are the mass numbers different? That of 16, 17, and 18. It is because of what? Isotopy. So that's that. Let's take more questions. Oxygen is a mixture of two isotopes, 16 and 18. Oxygen 16 and oxygen 18. Atomic number is 88. Oxygen is a mixture of two isotopes, 16 and 18. All the atomic numbers are the same, 88, with relative abundance of 90 and 10 respectively. 90% and 10% respectively. Okay. Now, the relative atomic mass of oxygen is what? So I have to calculate the relative atomic mass. So the relative atomic mass is equal to 16 times 90 plus 18 times 10 all over 100. And this is 16 times 90 is 1440440 plus 180 over 100, and this is plus 180 divided by 100. 1620 when we add that over 100, and this is equals to 16.2. So don't forget 18 times 10, this is 18 times 10, which is 180, was this, divided by 100. So 1440 plus 180, yes. I just want to cross check again. 1440 plus 180 equals 1620 divided by 100 is 16.2. So that becomes the relative atomic mass for that. Now let's take the next question. Different isotopes of an element are found in the following percentages: 9.0, 0.3, and 90.7. The percentages are this: 9.0%, 0.3%, and 90.7 and 90.7%. Okay, 90.7. If the masses of the isotopes are 22, 21, and 20. 22, 21, and 20. Calculate the relative, what is the atomic mass of X? So the atomic mass of X is equal to 9 times 22 plus 0.3 times 21 plus 90.7 times 20 all over 100. And this is equal to 9 times 22, we have 198 plus 0.3 times 21, 6.3 plus 90.7 times 20, 1814 all over 100. So we add 1814 plus 6.3 plus 198. 98. This is equals to 2018. 2018.3 over 100. And the atomic mass of the element X, when we divide by 100, we'll be having 20.2. 20.18. Okay, 20.2 approximately. So we have been able to see how, or we are seeing how the relative atomic mass of most elements are always having a point in them, it is because of what? Isotopy. So we'll be able to calculate the relative atomic mass by using the two principles, either the ratio or the percentage abundant method, to obtain that. That is the reason why chlorine will always remain 35.5 and so on and so forth. Let's take another question. Question 5. An element X with relative atomic mass of 16.2. So this time they're giving us the relative atomic mass. Let's write it here. Relative atomic mass of 16.2. Okay, an element X with relative atomic mass of 16.2 contains isotopes of 16.8, X, 16 and 8, and 16 and 8 with relative abundance of 90%. Okay, with that 16 and 8, relative abundance of 90%, and M and 8 relative abundance of 10%. What is the value of N? So remember how we do it. With the relative atomic mass will equate the mass number times the percentage and the mass number times the percentage. So this is 16 times 90 plus M times 10. But the relative atomic mass is 16.2. This is equals to 16 times 90, 1440 plus 10N. We make M the subject. So 10N is equals to 1440 minus 16.2. Okay, all right. Oh, sorry. Made a mistake. Our 100 is not here. Okay, sorry. So let's go. Don't forget that over 100. So now this is our 16.2 is equals to, let me multiply now. 16 times 90. 90 is equals to 1440 plus 10N over 100. We cross multiply to make N the subject. So this becomes 16.2 times 100 is equals to 1440 plus 10N. 16.2 times 100 is equals to 1620. So 1620 is equals to 1440 plus 10N. Let's come this way. So from here, if I make 10M the subject, this 144 will cross over to the other side. So I have 1620 minus 1440. So 10M is equals to 1620 minus 1440. 440 is equals to 180. So divide both sides by 10. Divide both sides by 10 to make M the subject. So this cancel. M is equals to 18. So the relative atomic mass here is 16. Here would be 18. So what we're doing today is to illustrate how isotopy affect the chemistry body or the element generally in chemistry. When you go to your the periodic table, you tend to know, or you are expected to know, the element, the first 20 elements, their atomic masses, and many a time we find it difficult to understand why are some of them having this 0.5 or that 0.5. And that chemistry will not be clear until you understand the principle or the chemistry of isotopy, where we say atoms of the same element with the same atomic number but different mass numbers. And we've been able to correlate and relate how the two principles which we can use, that of the ratio and the percentage abundance, any of them that you come across, sometimes the question may not be straight, just like this one, but you should also remember your change of subject of formula, which is very important in mathematics. Like I said earlier on, without the fervent knowledge of mathematics, we find it difficult to move around in chemistry and even in physics. So as time goes on, I'll continue to bring in some essential topics in mathematics which will guide us, or which will be a guiding line for us to be able to excel excellently in chemistry. So the change of subject of formula, for those of us that may not be very active in it, I will bring it up sometime in future. So for the time being, you take care of yourself. And don't forget to subscribe and press the like button. I see you again when I see you. Have a nice time.